Okay. So to get prepared for today's warm-up, I was a little bit I was in a tricky, maniacal mood this morning, and I gave you apparently a very hard, tricky question for your warm-up. Okay. Overall today, of course, we're going to be continuing to learn how to draw covalent Lewis structures, but our warm-up today is going to be the most challenging naming question you have had yet. This naming question, there are going to be 5 chemical compounds, some ionic, some covalent. If you need your covalent prefixes, here they are for just a moment. But for each one of these 5 compounds, I have given you the chemical formula, and I have also given you a name. But only one of them is named correctly. It is your job to figure out which one out of the 5 has been named correctly. Okay, you can use your drag and drop, use your periodic table, and see what you got, okay? Which one of these is named correctly? I'm gonna give you guys about 2 minutes to work on this. We'll say 3. We'll check in at 2 minutes, see how you're doing. So, I'm gonna call out a few names. This is not all of them, but I'm gonna call out a few names that got the correct answer. And I'd like you to either type in the chat or raise your hand if you want to explain which answer you chose and how you know that it is in fact correct. Omar, go ahead.
Chose Li2 sulfur, so lithium and sulfur. Lithium 2 sulfur. So lithium, since it's the first element, it's basically written normally without any prefixes, even if it has a charge 1, 2, or 3. And then so the other one, which is a sulfur, it doesn't have anything, so it's basically sulfur. And since it's the second element, the last 3 letters would change to IDE. So it's lithium sulfuride.
You are close. Your explanation is close. Karma, you want to add on?
Oh yeah. Since this is an ionic bond, you don't need to use mono and stuff like that prefixes. So it's gonna be just lithium sulfide.
Perfect. How did Karma know that this was an ionic bond? Sebastian and Naomi typed in the chat, lithium is a metal and sulfur is a non-metal, which is exactly correct. So lithium sulfide, Li2S, is the only one that is named correctly. Okay, so what I would like you to do now is on your screen, I want you to choose 2 of these and fix them. Okay, lithium sulfide was the only one that was correct. Each one of these other 4 compounds has something wrong with it. So I want you to attempt to fix them. Maybe if you did not choose lithium sulfide as your correct answer, choose that one and try and see if you can figure out the correct name using your classmates' explanations. Right, so do not worry if I did not get to yours since you updated it. I read through every answer twice that I saw, but we're gonna go through each one of these one at a time, okay? So the first one, H2S, hydrogen is a metal, sulfur is also a non-metal. And if we look, quite a few of you got this one correct. With non-metals, you always use prefixes for that second element. So this one is more appropriately named dihydrogen monosulfide. Okay. Third one, Li3 and 2. Just like the one above, lithium is a metal, nitrogen is a non-metal, so this is ionic. So you do not use the prefixes. It is simply lithium nitride. Okay. Can somebody explain what's wrong with the name for NF3 in this case? Most of you guys did this one correctly. How would we fix this one? Can we hear from somebody other than Omar and Karma? It's not because I don't like you, but it's because I got 30.
Yes.
What do we think? What needs to be fixed with the NF3 one?
The element.
The element. Very good, Sanu. Nitrogen trichloride would be NCl3, but NF3 is going to be nitrogen trifluoride. Nitrogen trifluoride. Very good. And then the last one, my friends. Look at your periodic table. We have P and F, both nonmetals. So a lot of you did correct the ending, which was trifluoride. But what element has the atomic symbol P.
Fast.
Some people are freaking out in the chat. The element P, atomic number 15, if we look on the back of our periodic table, is not potassium. It is phosphorus.
Oh my
Be
god.
very, very careful with those ones, okay? Chemistry teachers around the world like to confuse students by mixing up potassium and phosphorus and also sodium and sulfur. So be very, very careful with those. You did do the bond type correct by changing the ending to trifluoride. However, be very careful. The letter P stands for phosphorus, okay? Good work, my friends. We're gonna keep going. We're gonna do a couple of practice with what we learned yesterday, and then your asynchronous work is going to be an ed puzzle looking at how to draw Lewis structures for covalent compounds, okay? Yesterday we learned that in order to check a Lewis structure for a covalent compound, you are going to look for two things. The first thing you're going to look for is you're going to make sure that your total number of valence electrons is appropriate for the compound you are looking at. And then the second thing you're going to look for is that those electrons are arranged in a way so that everybody has a full valence shell. Okay, and so these two things are 100% important to make sure that you are drawing Lewis structures for covalent compounds correctly. Okay, you want to check the exact number of valence electrons and that every atom has a full valence shell. Okay, so on the next screen, I'm going to show you a compound, nitrogen trichloride, NCl3. In the chat, I'm going to show you nitrogen has 5 valence electrons, chlorine has 7, and because there are 3 chlorines, I'm going to multiply that by 3. That means you need 26 total electrons in your picture. So what I would like you to do, using that information, is the diagram that you see on your screen the correct Lewis structure for nitrogen trichloride? Why or why not? And you can type directly in the pear deck. I'm only going to give you about a minute. And if you think it is not correct, what would you do to fix it? Question in the chat asking to remind what the lines stand for. One line in a covalent Lewis structure, or one dash as it's more often called, represents 2 electrons being shared. Okay. All right, don't worry if your answer was not fully fleshed out. We're gonna look at these. A lot of you guys are correctly identifying that this is not the correct Lewis structure, because if we look here and we count, we need 26. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And if you notice I was counting by 2s, that's going to make life so much easier when working with covalent Lewis structures. And you'll notice that we are missing 2 electrons. Okay, and so this is not the correct Lewis structure because it does not have enough correct electrons. Okay, and if I look on the answers, I want to see, anybody got it? Nope. Can anybody tell us where those last 2 electrons will go to fix this compound? Okay. You can type in the chat, or Omar, thank you for raising your hand. Go ahead.
So it's gonna go to the one chloride on the right since it's missing 2 electrons.
You got it. Very good. And Sage got it in the chat as well. The chlorine all the way here on the right only has 2, 4, 6 electrons. So you know that it's going to get the extra 2 to use them up and also to fulfill the octet rule for that compound. Okay? Excellent work. So the next question, you're going to choose the one that is incorrect. The chemical compound we're looking at is CO2, carbon dioxide, and carbon has 4 valence electrons, oxygen has 6. I have 2 oxygens, so I'm going to multiply that, giving me that for a total of 16 total electrons. Which, spoiler alert, all of the pictures in the next screen have 16 electrons, so you're more so looking at the octet rule. Okay, multiple choice, which of the following Lewis structures is incorrect for carbon dioxide? Justin, let me read your question. Justin, more so, sulfur is going to be in the middle because there's only one of them. and 3 of the other element. And so whatever you ever have 1 of typically will go in the center to make as symmetrical a molecule as possible. Question in the chat, what do the X's stand for? The X's are just another way of showing electrons and being specific as to where they came from. So in compound A, the X's are representing the 4 valence electrons that carbon started out with. Similar to how compound C, it's the same thing, just color-coded. Okay, so the X's are still going to be electrons. They're just showing specifically where they started. Justin, if you're ever unsure, you go and look at electronegativity to tell you for sure which one. Okay. All right, for time's sake, I'm going to go ahead and lock your answers in. Happy to see most of us got this one correct. If we are counting, every picture has 2, 4, 6, 8, 10, 12, 14, 16 electrons, and pictures A, C, and D are showing the same exact thing. If you look closely at picture B, poor little old carbon is not happy. If we look at this picture, yes, we have used the appropriate number of electrons, but remember, when we're forming bonds, the goal is to make every atom have a stable octet. And in this picture, carbon only has 4 electrons. So as you are going to see in your Ed puzzle today, it's going to show you how to remedy this if you have run out of electrons when drawing your Lewis structures. Okay? The reason why A, C, and D are all showing the same thing is because if we look at letter C, in between carbon and the oxygen in the left, we're sharing 1, 2, 3, 4 electrons. Same with letter A, 1, 2, 3, 4. And letter D, they're just simplifying their image where everywhere there is a pair of electrons being shared, they replace it with a dash. 1 dash represents 2 electrons being shared. Okay, and so these pictures A, C, and D are all showing the same thing. And letter C here is, or letter B is not, okay? Question in the chat, how do we know which ones are being shared and which ones are not? The ones that are directly in between the 2 symbols are the ones being shared. In letter B, these electrons on the tops and the side of oxygen are not being shared. They are being held exclusively by the oxygen, okay? And so you want to look in between the letters to know which ones are being shared. That's another reason why chemists replace them with lines, because lines are only used to indicate electrons that are being shared. Whereas these extra lone dots on the outside are called just that, lone pair electrons, and you'll hear that vocabulary used today in your Ed puzzle. Okay? But to be respectful of time, if you look on over at Google Classroom, your assignment for today was posted. It is an Ed puzzle where you're going to learn the steps to draw these. Not learn them, you've seen me do it over the past couple of days, but it's going to ask you some check-in questions. These are going to be questions you ask in your brain as you draw them from scratch starting tomorrow, okay? In the Ed puzzle, most of the questions are actually notes that are going to be like pointing out the most important parts that you need to learn. And also it's going to recommend that you draw this stuff literally on a piece of paper, because trust me, it's going to make more sense actually drawing it out yourself than it would be just watching things move on a computer screen. Okay, and so you'll notice this is not due until tomorrow night, because if you want to ask any questions tomorrow in class, you are welcome to. We're going to be drawing these in class tomorrow using Nearpod's drag and drop and draw functions, and we're going to go from there. Okay, so if you think you got this and you have to go, you can feel free to leave today's Zoom call. But I do have office hours right now where if you want to stay and do a couple more examples, like confirming which ones are correct or incorrect, you are welcome to stay and do that, okay? But otherwise, if you're leaving, I hope you have an excellent day, and I will see you tomorrow. Hugo, if you want to tell us what day it is, you can type it in the chat, and I'll read it aloud to everybody, okay? Goodbye, my friends.
Miss.